For this problem number 3, I have the point 6, negative 5, 2. So that's P sub 0. P sub 0, which is x0, y0, z0, equals 6, negative 5, 2. And then I know the direction of this line. The direction of the line is given by this parallel vector. If two vectors are parallel, they have the same direction. So I'll have this, and vector v is 1, 3, negative 2/3. Now vector r is kind of what I'm looking for. Vector r is just some vector, x, y, z, where the point x, y, z is a point on the line. So the terminal point of r is a point on the line that I'm looking for. And I think I have everything that I need. Here's the equation. Vector r is vector r sub 0 plus t times vector v. And just plug in there and you'll have the answer, the vector equation. So I'm going to end up with x, y, z, vector x, y, z equals vector r sub 0, that's the position vector that has the point as a terminal point. So that's vector 6, negative 5, 2, plus t times vector v, 1, 3, negative 2/3. There's the vector equation for the line. And then for the parametric equation, I usually just kind of start simplifying this. I don't know if simplify is quite the right word, but you know, I'll start carrying out whatever arithmetic I can carry out. What do I do? T times this vector. T is a scalar. So I multiply t inside of that vector. T times 1 is t, 3t, negative 2/3 t. And then I can add corresponding components. So this is 6 plus t, negative 5 plus 3t, and 2 minus 2/3 t. And that's equal to vector x, y, z. And I haven't gotten the parametric equation yet. Now we are about to do that. So I'm looking at what I have here and say, well, vector x, y, z is equal to this vector here. The corresponding components are equal. And that is the parametric form of the parametric equations. So x equals 6 plus t, y equals negative 5 plus 3t, and z equals 2 minus 2/3 t. Parametric equations of this line. You could have probably gone straight to the parametric equations if you have, you know those formulas. Just plug in the corresponding numbers there. They did not ask for the symmetric, but if they did, well, let's go ahead and give it anyway. So for symmetric form, I would say, okay, well, x is 6 plus t, so x minus 6 equals t, and then y equals negative 5 plus 3t, y plus 5 over 3 is t, z equals 2 minus 2/3 t. So z minus 2 divided by negative 2/3 is t. And if you like, you can simplify that, or we could leave it like that. Let's see. If I simplify it, z minus 2 times negative 3 over 2. So that would be 3z minus 6 over negative 2. Okay, check that. Make sure I didn't make a mistake. I don't like going from here to here without writing more steps. Okay, so for the symmetric though, it's x minus 6 equals y plus 5 over 3, and that equals 3z minus 6 over negative 2.